Hi guys, you're welcome to Allogenous Ideas. In this tutorial, we are going to be talking about recursion in Python. We're going to be treating recursive function. Now, this is a topic that most beginners have issues with having to make a function call itself, but trust me, it is not difficult at all. Just follow along. So, recursion is a programming technique where a function calls itself to solve smaller instances of the same problem. It is like a Russian doll where you have a doll inside a smaller doll inside the other small doll. So that is it basically. In a previous tutorial, I used factorial as an example. So let's start from there. And I said um, while writing a recursive function, you have two things to keep into consideration. You have the base case, the case that terminates the recursion, and the recursive case as well. All right. In the case of the factorial now, the factorial n. So don't forget, I said we have the base case and we have the recursive case. Okay. So this base case, I'm going to be having if n equal to 0, then return 1. But on the other hand, else, if n is not equal to 0, then return n multiplied by factorial, then n minus 1. Now what I'm doing, like I said, recursion is used in a scenario where you want to break your problems into smaller parts. Okay, so I have n over here. Imagine that, just take let's take an example that n is 7. What I did over here is that I made this one to be 7, then factorial of what? 6. If you know what we call backward substitution in mathematics, that is exactly what you can liken what is happening here to. So you have n, which is 7. Like if you are taking, for example, n is 7, then multiplied by 6. When it comes into this place now, n is 6. That will be 7 times 6 times factorial of 6 minus 1, which is 5. It continues like that till it gets to 0, where it returns 1. Alright, so let me say print factorial of 4. Run this, you see it's giving me 24. Alright, that is how factorial works. In this example, the factorial function calculates the factorial of a number n by calling itself with a smaller argument until it reaches the base case. Alright, so let us visualize recursion. What does it look like? Let us do a bit of visualization for recursion. So let's do this thing. Def countdown. So for this countdown now, let us have n. Then if n equal to 0, print go. Alright, then else print n, then countdown n minus 1. So let me print the countdown, maybe 10. Print countdown 10. Run it. So you see what I'm having over here now. Something is wrong somewhere. Something is wrong somewhere, because I'm getting none. After printing go, so it normally is supposed to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then if it is 0, just go. Okay, yes. Everything is working fine. So here the countdown function prints numbers from n to 1. Okay, and don't forget n is 10 down to 1. Then when it gets to 0, it prints go instead. So demonstrating how recursion can be used for repetitive tasks. Okay, So let us treat some other examples of recursion. The first one we are going to be treating is how you can add up all the elements in a list, all the numbers in a list using recursion, and that is very very simple. You can just say def sum lists, then you pass in the lst, then you come here and say if not lst, then just return 0. Okay, else, no, I'm not supposed to put this, else, so I just wrote the base case. Now the recursive case, return lst, indexing the first element, then plus some list of lst excluding the first element. Okay, so that is what I want to do. So for the first one, it will be the first element, then I'll sum up the list again excluding that first element. So come here and return some list of maybe 1 2 3 4 and 5. So no, that should be print, not return. That should be print. So run this. You see, it's giving me 15. 1 plus 2 is what? 3 plus 3, 6 plus 4, 10 plus 5, 15. So that is correct. Then the second one we are going to be looking at is recursive power calculation. Recursive power calculation. So if I have, like, I can write a function, I can say power 2 comma 3. So basically 2 is going to be the base while 3 is going to be the exponent. So let's check it out. How can we do that? You can do something like this: def power base comma exponent. So now if the exponent is 0, then just return 1, because anything raised to the power of 0 is 1. Else return the base multiplied by power base comma the exponent minus 1, and that is it. So you will keep reducing the exponent until the exponent becomes 0. So when it becomes 0, then obviously you just return 1. So but you can't use this to calculate for negative powers. That we have to make some modifications to it, but I think it's good for explanation. So I can say result equal to power of maybe 2 comma 3, which will be 2 raised to the power of 3, which will be 8. So print result, save this and run it. You see, it's giving me 8. What if I do for 2, save and run it? You see, I have 16. So here the power function calculates the result of the base raised to the power of the exponent using recursion. In this last example, I'm going to be showing you how you can reverse a word using recursion. How to reverse a string using recursion. So let me say string, no, or let me say word equal to university. So I want to reverse university now. This is supposed to be a string. So I can just say def reverse and now say word. Now what I will say is if the length of the word equal to maybe 1, return word. Okay, else return word indexing the first element plus word, no, actually indexing the last element, which is -1, plus word indexing all the elements except the last one, and that is it. So copy, print, reverse word. So run this. You see, this is the mistake I made. Instead of having word -1 plus word, what I'm supposed to do is reverse word. Yes, this is what I'm supposed to do. Sorry about that. Let me clear my terminal. So run this. Yes, university. Exactly. So that is it. That is how to reverse a string using recursion. So recursion can be a powerful tool in your programming arsenal, but it is important to use it wisely and understand that it is the right tool for the job. You can start with the simple examples like the ones to build your understanding and gradually tackle more complex problems as you become more comfortable with recursion. So thank you very much. That will be end of recursion for now. Don't forget to like the video and subscribe to the channel. If you have any questions, the comment section is open. Thank you very much. I'll see you in the next tutorial. Bye for now.